Welcome to EDU World Space.
So in this video, we're going to work through question 86 from chapter 20, which says hydrazine is somewhat toxic. Use the following half reactions to explain why household bleach, a highly alkaline solution of sodium hypochlorite, should not be mixed with household ammonia or glass cleaters that contain ammonia. And the two half reactions we have are ClO minus plus H2O plus 2 electrons yields 2 OH minus plus Cl minus. And the reduction potential for that half reaction is positive 0.9 volts. And then our second half reaction is N2H4, which is hydrazine, plus 2H2O plus 2 electron yields 2NH3, which is ammonia, plus 2 OH minus. And the reduction potential for that half reaction is negative 0.10 volts. So what can we learn from these half reactions? So these half reactions together tell us how ammonia reacts with hypochlorite. We just need to write them in a way that we can add them together so that our electrons cancel from both sides. And then our two half reactions will together be a redox reaction. So the way these are both written right now is as reduction half reactions where we're gaining electrons on the reactant side of things. So we want to write one of them as an oxidation half reaction. Since we're having a redox reaction, we need both reduction and oxidation to occur. So which one are we going to flip the direction of? Well, we're going to flip the direction of the second one, and that's because the reduction potential for that half reaction is negative. So a redox reaction occurs spontaneously when the standard potential for that cell is positive. So we're going to flip the half reaction that will give us a positive standard cell potential when we add these together. So we're going to flip the negative reduction potential half reaction. So that's the second half reaction. And we also could have figured that out just by saying, well, I want to know the reaction between hypochlorite and ammonia. And since ammonia is a product in the second half reaction, I want it as a reactant. So you could have also figured it out that way. Either way, we're going to flip the second half reaction, and when we do that, we're going to flip the sign on the reduction potential. So now we flipped the second half reaction, and the reduction potential has gone from negative 0.1 volts to positive 0.1 volts, and we can add this together. So what cancels from our equation? Well, first of all, our electrons cancel. We have 2 electrons in each half reaction. And then we have 2 hydroxide ions in our products and our reactants. And then in our reactant, in our first half reaction, we have 1 H2O, which is going to cancel with 2 H2O in our products of our second half reaction. So what we're left with is hypochlorite, ClO minus, plus 2 ammonia, NH3, yields Cl minus, plus N2H4, hydrazine, plus water. So the reaction between hypochlorite and ammonia produces chloride ions, water, and hydrazine, which we know is mildly toxic. So since the cell potential for this reaction is positive, we know that it will occur spontaneously. So we have a spontaneous reaction producing a toxic molecule, hydrazine. So the reason you wouldn't mix bleach and ammonia is so that you don't produce hydrazine.